Hello guys, today I'm going to present you algorithm. This is a voluntary project for a course called Algorithms for Network Systems. This course is provided by Technische Universität Berlin and is hosted by Professor Schmidt and PhD Arash. You can find more information about this course online when you Google algorithm. Professor Schmidt provide this sheet, and in this sheet we have one interesting algorithm, which is algorithm to breadth first search spanning tree, and this is Dijkstra favor algorithm. It's also here, but as we can see here, we have Dijkstra style algorithm, which chooses root, then if ask all other algorithms or other nodes to join his spanning tree. If not already is in spanning tree, he will say no, but if he is no, he will say okay, acknowledge, no acknowledge. And we're doing this as long as there is no new nodes discovered. And as we see, the presentation was slides, and also there was a description. And for me, when during the listening, like I was already listening 1 hour about algorithm, and it was quite intuitive, this algorithm. I didn't understand it first time. That's why I decided to make this video and also go more into this algorithm. Just to have better understanding of this algorithm, I decided to, let's write the code. And if I decided to write the code, then I decide, maybe it will be more interesting, instead of having slides, to make GIF. Like GIF image, where we can see exactly what is going. And that's why I make a program which making this type of GIFs, which present you distributed BFS in Dijkstra favor. I was thinking to make more these GIFs, because this drawing GIFs can be quite repetitive. Yeah, because it's only function, but just Dijkstra was very time consuming, and I decided to make it more nice and more beautiful, like add more stuff. And then you can find this code on my GitHub repository. I will link the code to GitHub in the description of this video. And also this video will be linked in GitHub repository, like if you are from different site. Okay, let's jump into the code. First we make we import our dependencies, but we will make it go there in a moment. We import our class called Dijkstra. We make this folder called utils, and we import globals. Let's start with globals. Globals, if you wanna use this program just like repetitively, you can change the seed. Yeah, like we can see this, we have here our gifs, and if you change seed, save the file, and then we start our program. Yep, it changed how graph is structured. Is very useful, because sometimes if you change the number of nodes or edges, the GIF can be in very weird position, but we wanna have like it randomized, because this library also trying to make it as good fit
in pyplot because underneath is pyplot library. Also, like this table and these nodes are in can be changed in pyplot library as a Python pyplot commands. And now let's see what we have. In main we have nodes. Then because it's BFS we need to choose root. And next we have edges. Yeah, this is just edge list. Later we'll try to change a bit. Then we define our graph. And we put our graph into the Dijkstra algorithm. Let's see what is defining graph. Defining graph takes nodes and edges. Nodes, just adding nodes and add this to class graph and returning this class. Then we have edges, the same with edges. Then let's go to Dijkstra algorithm, it's more interesting. As I say, I have a problem to understand how this algorithm works. That's why I decide to name the edges which take a part in each face by colors. Orange edges and nodes are as we see free, like for example in first face is 2, 3 and 4, in next is 5. Okay, we have one bug in code. Let's see why. Okay, let's leave it this way. I think we can change this idea just here, like live coding example. Oh, okay. The problem is, as we see in second phase, this is not like good color, and let's live code debug it. Live code. First, yes, we see. First is this, like just this now. This is second row in this phase, and then we have problem because orange edges are null. Ah, this is good. Green nodes are let's see what will happen if we okay, I will pause the video for a moment. Okay, I'm back a bit moment later.
I found the mistake. Problem was that here we adding our nodes to BFS, and because we adding here the node to BFS in utils, the coloring is made in simple way, and the last color is like on the top layer, and I had to change these two lines. Yep. Yep. I need to change them because green was the top layer. And now it's okay. We see that new nodes are yellow when they send a acknowledgement, and now it's good. Yep, I'm adding it to Git, and now it will be okay. Let's go further in our algorithm. When it is okay, we start with orange edges, orange nodes, red edges. Red edges are edges when no HK is sent. BFS is our tree we want to have. No edges are edges we know, like these nodes are like yellow and red starting to be no edges. Even if it's not in tree, we treat it like it as no edges. Before I make a mistake and I just iterate for all edges in graph, but it was a mistake because we don't know we should not assume how many edges are in graph because we simulating distributed BFS, and we need to start with, oh, what I am this node and I sending message to other nodes, and I know only that. We don't know, we cannot use the all edges, and as we see, we doing this as long as we have orange nodes. Yeah, orange nodes, as we see now, it's correct, are new nodes which are discovered in new phase. Okay, then as we start, this is drawing the graph just with green dot here. Next we simulate sending first HK, and orange HK is when HK is okay. Yeah, I will join your tree, and red is if not okay. As we see, to get red, we need to have our condition that two nodes are already, yeah, this is one side of word edge and second side edge are already in nodes. If they are not, we just add two, and this is a Python trick to delete repetition from this list, and we just delete repetition, we add two of them and then delete repetition, and then we have our nodes. Also, when we run it again, we can see that we have all these phases and nodes in just as a return, and yeah, we can think algorithm which based on that, and we can use this output maybe if you wanna to compare to different solution, compare this algorithm to different solution, and it can be show more highlights. Now let's go to how we're drawing the graph. Yeah, we have define. We don't use this. We have defined our graph, which already talked about it, and now we can see how this graph. Maybe I will display also this graph somewhere else to make it more visible. Oh, this is very good. And close this. And first we draw our nodes. As I mentioned, the orange is top color. Now blue is starting color. All nodes are blue. Then we overlay with green, and then we overlay this with orange, because just to save one slot we adding orange one to the logic of our application before we display it. That's why was this mistake on the beginning of this video. Now we go to edges. These are just dark edges. Then we add green color, as I mentioned ago, orange color and red color. And there are a list of these edges, and we need to manipulate with this list. And we add this list in this Dijkstra file. This is how legend is plot. It's not maybe the best look like and the best code practice, but it works. And there's a display, and also we can use pyplot comments. Next we save our each photo in our images file directory. It's local directory. Maybe it should work on other computers. The path is defined in globals.py. Then we save it and close pyplot. Then main function we have gif function, which scan our directory. The directory called images. Then we append the file names to list array, and then we for each file add it to this gif. And because we can change the root, we here can specialize, like for example 5, save file and run. Because we can change the root, we have to delete all photos from previous, because depends on the number of phases depends on the position of root. And we can also define number of phases because it's in slides, this knowledge. Quickly we count that number of phases is depends from radius from root. And now we can go to definition of radius, and radius is max distance between another nodes. And if we have graph which two nodes are very far away, for example, we can add one more node here to also test this is functionally good. We're adding 10th node here and adding 410 edge here. And now we run our script program. And as we see, we have now 5 phases. Oh, something is not going great. In which phase is problem? Interesting. Let's debug it again. I will back in a moment. And back to recording. We have very interesting bugs because in our when we read directory of our where we hosted the files, problem was that this is a string value, and as we see, the 10th value goes inside the graph, and that's why it was something weird going on. But now it's so tested that I'm so curious that there's no more bugs inside. But as we know, programming is most time debugging. Yeah, and we can go back to previous version before finding this bug and see how it's going. No, it's not going because also here was changed. And now we can go and see what was a problem. Yeah, and now it's a problem. Yeah, as we see, this final tree moment. Yeah, but now it's going well. And we see that there is a problem. Yeah, like 10 in string is less than 2. But now we fix this bug and now it's working very well. And slowly we can end this video. Let's go further and close it. Yeah, now bug fixed. Commit, synchronize, don't show this window again. And as we see here, we can observe that it depends from radius, like how many hops is from 5 to 10. And now we can change root to 9 and see how many phases we will have. Yep, I think here we have 4 phases. This is just going too much because there's no new nodes discovered in 5 phases, but it's just one too much interact, but there is no problem. And now we're going to main and see what happens if we go 9, yeah, like this node, save and run. Maybe again. One, two, three, four. 1, 2, 3, 4. Yeah, as we see, there was the same distance. Yeah, maybe 1, 2, 3, 4. Maybe we can change like 1, 2, 3, like this 3 now. It's quite in center. And see, and just let this print. And now go this. Yeah, as you see now we have less phases. 1, 2, 3. Yeah, because this is too much too much row. But I will leave this way because it's not big problem, because we also see that there's a null array. Thank you very much for attention. Sorry for these bugs, but this is a part of grinding process. And I hope you don't mind me. And however, I try to fix it and also show how I fix it, and I hope it was interesting video. Thank you for watching, and hopefully I will make more this type of video, because it was quite fun to make this one.